Ready?
Yes.
The next formula is a criteria based on yield. This is internal rate of return. Internal rate of return is, if you see, it is the same formula except that instead of discount rate here we have R here. Instead of I, we are using R symbol here, and we make the net present value equal to 0, which means that when discounted benefits minus discounted cost becomes equal to 0, at that rate is considered as internal rate of return. And its advantage is it is not using any discount rate. The project can be considered economical if internal rate of return is more than acceptable discount rate, and higher the internal rate of return of any project, that is the better one when we are ranking the projects. The next is the payback period, and we have simple payback period and discounted payback period. The simple payback period is when the revenues minus cost becomes equal to 0. That time is your T prime is your payback period, and the same formula can be also found easily if your the cash inflows per period are same. So you have initial investment divided by cash inflows per period. Payback period is equal to payback period. As you can see over here, there is no time value of money concept coming. This is a simple payback period. If you would like to have the discount rate to be used as well, which is more realistic, then the discounted payback period is used, which is the discounted benefits minus discounted cost when that time when they become greater or equal to 0. That time T prime is the discounted payback period.
Doctor, so again you are bringing everything to the present time.
Exactly. We are all everything bringing to the present time, and we can show you with the coming example. So next example we are going to show you about the discounted payback period and simple payback period. Let's see this example here. We have initial investment of $200, and the net cash inflow is as given below here, which is at the end of first year it is $100, or start of first year from 0. If we say 0 is the initial year, then 0 and 1 is at the end of that. So it is at end $100, and second 100, and then third is 81.7, and 4 is 100. Now the simple payback period is telling us that in 2 years time our initial investment at 0 time will be back. We will have the amount which we have spent will be back to us. This is a simple payback period. Let's say if the discount rate is 20%, the discounted cash flow will look like that, which is given here. You have first year, this $100 is discounted 1 year once, so it is 83.3 1 year discounted. This is the another is $100 is 2 year discounted. 81.7 is 3 year discounted, which has become 47.3, and this 100 has become 48.2 after discounting 4 years. So the discounted payback period is, now if you add these first 3 years, they are equal to, in our initial investment, $200. This means that in 3 years we will have the payback period if you take into account the time value of money. And also we can note that the discounted payback period will always be greater than the simple payback period.
So doctor, if I'm correct, for the discounted rate we always go back to the present time. So 83 is present, 69 is present, 47 is present,
exactly,
48 is present.
That's right. Thank you very much. Now we have some examples. We will, whatever the concepts we have learned, we will see some examples here. Suppose a new restaurant that just opened up had incurred an initial cost of $5,000 and is expected to stay open for the next 3 years. The net benefit for the next 3 years is expected to be $3,000 per year. What is the net present worth of the investment? Should the investment have to be invested? The discount rate is 9%. So we have initial cost is $5,000, and we have the revenues coming as $3,000, and we are finding out by net present value. Net present value is, remember that it is the discounted cost minus discounted benefits minus discounted costs. So we have all the benefits are discounted here minus this initial cost. We have the net present value of 2593.88, and you can see that the question is asked, should the investment have to be invested? Yes, any investment net present value greater than 0, it is a good investment. So since NPV is greater, the project should be accepted. The next example is the same example. We are asked to find out the internal rate of return, and here we put net present value equal to 0, and instead of I now fixing the discount rate, we are going to find out this rate. So here R and R are there, and this kind of problems can be solved iteratively. We can assume some value of R, let's say 10%, and find out what is the net present value. If it is positive, we increase R, and then R, if for example initially we put 10%, we found NPV is positive, then we increased to 50%, and we saw that the net present value is negative. So we keep iterating with on the positive side, from the lower side we start increasing, and from the higher side we start decreasing. Eventually we will have the IRR equal to 36.31%. Nowadays we have built-in formulas in Excel, etc., so they can do easily our job. Let's see example 3. We have two projects here, project A and B, and their costs are, initial costs are given at 0 time, and revenues at the end of 0 year, which is start of first year. So this is 215,000. IRR is calculated 150, and net present value is at 10% is 82 and 3636. Here we are trying to demonstrate that if we are going to rank these projects according to IRR, we will see that project A is a better choice. But if we rank it according to the net present value, you will be 3,636 richer. So you net present value give a more comprehensive approach here.
So here, if I may, for example, to find IRR, since there is only 1 year is involved, can I do eyeballing?
Exactly.
100 and 200, therefore 100%.
Yeah.
10,000, 15,000, 5,000 difference, therefore 50%.
Exactly.
And the reason is because it's going to be after cross multiplication, it's going to be linear.
Exactly.
We should be able to solve this using a linear calculation.
That's right. Even for 2 years we have quadratic equation, so that can easily be solved as well. Then we have 3 projects here, A, B and C, and we have 3 years of revenues here, and initial costs are there. The question is asked, what is the net present value at 10%, and what is the payback periods. As you can see over here, the payback periods of these 3 projects are all 2 years. In 2 years you will get your initial investment. But if you see the net present value, the third project, the C project, is bringing a lot of revenue, a lot of money is there, so net present value is very high, 74,000 or so, which means that the payback period is a near-sighted criteria. It doesn't look far beyond when the payback is done. So there may be more revenues coming in the future for some projects, and it may turn out that the ranking may be not that great.
So basically here the payback period does not necessarily capture the growth that the company might have in the 3rd year or the 4th year after the payback is done.
Exactly. Thank you very much for nice explanation. Thank you. And then we have the example 5 here. We have again 2 projects here. We have initial costs and the revenues. We have net present value and benefit cost ratio, net present value at 10% and benefit cost ratios calculated. And you can see from here also that the ranking are different. If we look at project A, benefit cost ratio is 2 and project B, benefit cost ratio is 1.27. So project A is better because it has a higher benefit cost ratio. Whereas if we look at net present value, project B is better. So again, we can say that the ranking could be quite different with different criteria. And then in conclusion, we can say that in case where a discount rate is reasonably established, present worth analysis is certainly the most comprehensive approach. When discount rate is unknown or fixed at artificial level, the rate of return provide more useful information, and payback criterion is useful for quick preliminary assessments where we have several projects, hundreds of projects, companies do many projects, so you can use a payback period as a preliminary assessment. So this example, we are going to see it next time, I suppose. Then I will just read this example here. Consider hydroelectric project with a capacity of 120 megawatt, average annual energy generation of 600 gigawatt hour per year, a total cost of $150 million, a construction period of 5 years with cost disbursements of 20% each year, and a useful economic lifetime of 50 years after the start of operation. The annual operation and maintenance cost will be $1.5 million and the interest rate is 12%. There is no inflation. Find the average unit cost of energy. So I leave it over here, think about it, go and do homework on this, and we will discuss this next time.
So doctor, if you explain some of the keywords of this assignment, I would appreciate that. For example, what does disbursement means?
Disbursement means that not all $150 million are required at the start. So such kind of projects, if we are borrowing money, we will be borrowing money in tranches, in disbursements. So we are borrowing, let's say 20% first year, 20% next year, and so on, so that the interest during construction is less. If we borrow it at the start $150 million, the interest will be higher. So we borrow how much money is needed, and then next year we borrow again, and so on.
So is there any capital cost here, the original cost that I need to calculate?
The original cost of this is $150 million, but because of disbursement, there will be there is a construction time here, 5 years, because we say that the construction period is 5 years and the cost disbursement of 20%. This means that $150 million, we are spending $30 million each year. But then there will be interest during the construction. After that, the operation of that project will start.
So if I wanted to see the benefit or revenue versus the cost, what components are the cost and what components are the revenue in this exercise?
Okay, here we are not worrying about the revenue, but we have energy here. So we can find out the energy cost. We can easily make it to revenue also if we know that how much we are selling this energy. We are given 600 gigawatt hours per year. So we are asked to find out the average unit cost of energy.
Thank you.
All right. Thank you very much.